At this point, as I was talking to a friend of mine, we might see you, July 4th. We'll just have one big party out on the football field whenever school's out at the same time. Who knows? With all these snow days, might as well just have a 4th of July barbecue. I don't know. So, whenever we determine the value of n in the expression, so if we had exponentials, and if we had 3 to the nth power divided by 3 to the second power, and then it would be equal to 3 to the fifth, what would we do, or what are we doing whenever we divide exponentials? What are we doing with the exponents? We're subtracting. So if we would need to find, what minus 2 would give me 5? 7. Okay? So depending on how you would want to solve this, you could either hopefully use a little bit of common sense and say, well, 7 minus 2 is 5, and we would just write down that n is equal to 7. If you would do this mathematically, and you needed to get rid of this number, you would multiply both sides by 3 squared, and we would have 3 to the nth power equal to 3 to the 5 plus 2. Well, n is equal to 5 plus 2, which is still 7. Now, realistically, you're not going to do all that work whenever you can look at it and say, hey, 7 minus 2 is 5. So 7 is what we're going to plug in there, right? Okay. Same way here, if we have, on 2, if we have x to the 4th divided by x to the nth power, and it's equal to x to the negative 2. So what are we going to take away from 4? What are we going to subtract from 4 to give us negative 2? A 6. Okay? Again, a lot of these, it's hopefully common sense as far as what's going to happen as far as whenever we solve these. If you need to, do it mathematically and go 4 minus n equal to negative 2, and you subtract 4, and get negative n equal to negative 6, and then say, well, it's n equal to 6, that's fine. Do that. Okay? But some of these, I think, or hopefully we can just look at it and say, all right, this is what it's supposed to be, so we're going to go from there. And knowing our rules in terms of if we're multiplying, then we're adding. If it's division, we're going to subtract. So how does that fit in with whenever we have any sort of log, okay, just like exponentials? Whenever we have different properties, whether it be adding or subtracting, multiplying, depending on how you want to look at it, whenever we multiply two exponentials, we are adding the exponents together. Whenever we do a logarithm, okay, that's if the bases are the same. Same way, if we have bases that are the same with a log, and we are multiplying two values in our of statement, so if it's like log base b of m times n, we can rewrite this as, and we can, what is called expanding, of log base b of m plus log base b of n. Same way works for the quotient property. If we're dividing, whatever's on top is going to get subtracted by whatever's on the bottom. Same way whenever we have a power property with an exponent, okay, it's a power of a power. Okay, the only thing different here is whatever our exponent is, that number's just going to go out in front. It's going to get multiplied just like it did with an exponential. Okay, like we've talked about for close to a week and a half, 2 weeks now, logs and exponentials are really just sister and brothers of each other. Okay, they're just siblings. They're just a little bit different. They're a little bit opposite of each other. So if it says that I have log base 3, which is about 1.585, and log base 2 of 7 is about 2.087. So if it's log base 2 of 3 divided by 7, what am I going to do with my two values? How can I rewrite this logarithm. Can't I just rewrite this as log base 2 of 3 minus log base 2 of 7? It's division, so we're going to subtract. Now, what value am I going to give for log base 2 of 3? What is log base 2 of 3 equal to, or about? 1.585. So instead of having log base 2 of 3, I'm going to have 1.585 minus, what number am I going to have for log base 2 of 7? 2.807. Subtract the two values. I'm going to be at negative, what, 0.8? 0.7? 48? Is that right? Huh? What's my value? Negative 0. Oh, I was going the other way. Two. So, same way with B, if I have log base 2 of 21, the only values that I have here are 3 and 7. What's another way that I can write 21 with the numbers 3 and 7? 3 times 7, right? So, this is really the same thing as log base 2 of 3 times 7. So how am I going to rewrite this? What am I going to do with my two values? I'm going to add them. So I'm going to have log base 2 of 3 plus log base 2 of 7. So 1.585 plus 2.807. Add everything together. 4.492. Oh, 93. There we go. Now, same way on C, but I have log base 2 of 49. So, depending on how you want to do this, there's really two different ways you can do this. I have log base 2 of 3, and I have log base 2 of 7. How do I get 49 with the numbers 3 and 7? 7 times 7, or 7 squared, right? Okay, so on this one, you could do it really two different ways. Okay, it's going to come up with the same thing. I can either have log base 2 of 7 times 7, or I could do log base 2 of 7 squared. It's going to give me the same value. Okay? It can't change its value. It's just two different ways that you could do this. I could either make this to where, if I keep this one in blue, if I have log base 2 of 7 plus log base 2 of 7. And I take 2.807 plus 2.807 and I add those two values together. Okay, I get 5.614. Okay. Same way, if I take the other one, and we'll just make that one orange, what did I do with the exponent from my property above? Where does that 2 actually go? It goes out in front. So really I'm just going to take 2 times log base 2 of 7, which is 2 times 2.807. Believe it or not, it's going to be the same exact value of 5.614. Okay? You can either do it the orange way or you can do it the blue way. They're both going to give you the same answer. Okay? But you have either option. Okay? We didn't use the log base 2 of 3. That's okay. There may be times whenever you're doing it this way that you may not use a certain value. One that's not up here is what if we would, maybe I have one down here in my other ones. I don't. What if I would have had, and so instead of like on that second page where it says log base 6 of 64, what if I made it like 1 over 64? What would I have done to, did I do anything with the log base 6 of 5, or did I do everything with the log base 6 of the 8? Like if it was log base 6 of 1/64 instead of log base 6 of 64. What did I do to the 8 before? Like what is another way to write 64? Huh? Or eight squared, right? So couldn't I write it like this? Log base 6 of 8 to the negative 2. So if you have a fraction with a value, it's going to have a negative exponent. So like where would this negative 2 go? It would go out in front, right? So if we were to actually be solving this, I would just have negative 2 times the 1.61 or 116, excuse me. Does that make sense? Okay, does everybody see where I got the negative exponent? Okay, or how I got the negative exponent? If it's a fraction and it is dealing with, if you don't have a fraction as far as your of, like of log base 6 of 8, I can rewrite 1/64 as 8 to the negative second power. Okay. So from what we just talked about, okay, it says expand the natural log of 5x to the 7th divided by y. So we're going to write this all as one thing gets one term. Logs and natural logs are going to do the same thing. Okay? If it's getting multiplied, or I'll give you a little hint, if it is positive, okay, or if it's on the top side of your fraction, that's going to have a plus in front of it. If it's on the bottom side of your fraction, it's going to have a negative in front of it. Just like whenever you have a negative exponent, where does a negative exponent normally go as far as your fraction is concerned? It goes on the bottom side, right? So whenever you do this, what I would suggest is I would try to run everything lengthwise instead of, so like if I have natural log of 5x to the 7th divided by y. Separate everything out like as far as top and bottom first. So natural log, I'm going to write everything the same way. So if I have the natural log of 5x to the 7th minus the natural log of y. Is everybody good there with what I did? Basically took it out and it's not a fraction anymore. It's just one long, everything's on the same playing field and everything's on the same level. Now, from here, I want to look at each individual part. Once I get everything on the same level as far as a positive and a negative, then I want to look at each part individually. So the first thing I'm going to do is look here. Do I need to, with the the natural log of 5x to the 7th, is there anything that I need to break up? Is there anything that's still getting multiplied or divided within that problem, or that part? Anything that's getting multiplied. Not the 7, but the 5 and the x to the 7th. So of what's circled, I need to separate it as the natural log of 5 plus the natural log of x to the 7th. So what was in the circle now is here in the box. Okay, that minus the natural log of y, nothing's going to change. That one is completely finished. It's just kind of along for the ride now. Because there's no exponent, there's nothing that's getting multiplied with it, so it's just kind of along for the ride. I can never end any sort of expansion of a logarithm with an exponent still there. So the natural log of 5, can I expand that any more than it already is? No. What about the natural log of x to the 7th? Yeah, what am I going to move? Or what still needs to be expanded out of what's circled? Where's the 7 going to go? Out in front of what? Is it going out in front of everything or just that certain part? Just that part. Okay, so it's going to be the natural log of 5 plus 7 times the natural log of x minus the natural log of y. This is my final answer. The only time an exponent will go out in front of two parts is when everything is getting taken to a certain power. So like on example 3, where I have log of 6 over 11 all to the 5th power. You can do these so many different ways as far as what you do with the log, like the 6 to the 5th power. If you want, to be perfectly honest with you, you can go ahead and take the 5 and put it out in front. What I would suggest, so then you don't lose anything on one like number 3, is take that 5 to each power and rewrite it as log of 6 to the 5th over 11 to the 5th. That way you know that each part is taken to the 5th power. If you try to put it out in front, you could, and I'm going to write this, but you don't have to. We could write and put 5 times log of 6 over 11. And keep it all in parentheses. It's still going to give you the same thing, but I will tell you, whenever we do that with the orange, usually what happens is that 5 usually only gets put with the first part and not the second. So that's why I would stay with what's in purple and go this route. So the first thing I want to do is I want to separate everything out, and I'd have log of 6 to the 5th minus log of 11 to the 5th. Now you may not have the power, but I'm going to white this one out so I can just keep going. Yours may fit. I don't know. Now from here, this is where I would then take each 5 and put it out in front of each part, to where I can have 5 times log of 6 minus 5 times log of 11 to get my final answer here. This is completely expanded. Okay. If you want to go the route in orange, that's completely fine. I have no issue in that. But usually what's going to happen is leave it all in parentheses and then take log of 6 minus log of 11. Again, if you don't put it in parentheses, what happens, or what I've seen happen a lot of times, is students will just give the 5 to the log of 6. Okay, and they won't give the log to, or the 5 to the log of 11. Okay, it's parentheses, so everything is going to get that same value. Again, it's completely up to you as far as whatever you see fit. But if you go the route in orange, make sure you put a parenthesis around whatever you do. Okay, so then you get in the habit, because you're kind of programmed already to have a parenthesis and distribute everything in there. Okay, we get the same answer, and that's what's supposed to happen. But I will tell you, on ones like 3, if everything's in a parenthesis, I would just give each part that 5th power. So then you don't forget to have a 5 in front of each logarithm or natural log, whatever you're dealing with. So in terms of condensing, you do everything the same way, you're just putting everything back together now. Okay? So what I would suggest is to kind of go in a certain order, is to look to see if there's anything out in front first. So what I mean by that is, if you have anything that is getting multiplied, is there anything that's getting multiplied in front of the log of 9? No. Is there anything getting multiplied in front of the log of 2? Yes. So if there is that case, then I want to take that 3 to make it the power. So then I can have log of 9 plus log of, it's really up to you as far as if you want to leave it, if it's a variable, leave it as a variable. What's 2 to the 3rd power? What's 2 to the 3rd? What's 2 times itself 3 times? 8. And then minus log of 3. Oh, probably need that 9 in there, don't I? What am I going to do with those 2 parts? What am I going to do with the 9 and the 8? Multiply them. So if I'm going to multiply them, what is 9 times 8? 72 minus log of 3. How can I rewrite log of 72 minus log of 3? Log of 72 divided by 3? What's 72 divided by 3? How much? There you go. This is completely condensed down. Okay? Condensed meaning the less you have, the better off you're going to be. Okay, but always take, if you have a number that's out in front, put it as a power. If it's a subtraction, that value is going to go on the bottom side. If you can divide, if you have all numerical values and you don't have exponents, or you don't have variables, then go ahead and take it all the way to whatever value or whatever number it has. If it's a variable, if you have an x or a y or a q or a z or whatever, then leave it as is. But if you have a numerical value and you can divide 72 by 3, divide 72 by 3.